We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today we will discuss the problem of the day for 10th December, that is maximum XOR subset. So please give me a +1 in the chat and like the video if my voice is clearly audible to everyone and my screen is also visible. And then after some time, once everyone else joins in, so we'll begin ahead with this problem. So please consider giving a +1 in the chat and like the video if you haven't, so that we can begin ahead with today's discussion. Okay, so I'll just wait for a couple of minutes for everyone else to join in, and then immediately I'll begin ahead with the problem of the day, that was for 10th of December. Just quickly let me know if everything is fine, if my voice is audible and the screen is also visible, and then I'll start. Okay, so talking about this problem, this is a Kirthana. Hi Kirthana. So this is a medium level problem and its accuracy is 68%, which is good considering about this problem. Also the number of submissions are pretty low. I think it is added somewhere near. Okay, right. After this, talking about this problem, so you have been given constraints and everything as well, so we will discuss about all those things. So shall we start? If everything is fine, then please give a +1 in the chat if we should start with this problem. Shall we start? Okay, right, so let's start with this problem. The problem name, as you know, is maximum the problem name is maximum XOR subset. So you have to find, you have been given an array which consists of n integers, and the task is to find the maximum XOR value of elements from all possible subsets. Okay, ultimately what you have to do is you have to find the maximum XOR value of the subset. Okay, you have to find such a subset which is containing the maximum XOR value of all of the elements from considering all possible subset, right? So let's say that we have this test case where n is equal to 3 and you have 2, 4, 5. Okay, if n is equal to 3, if my n is equal to 3, you have elements 2, you have 4 and you have 5, right? After this 2, you have 2, 4 and 5. Okay, right. So what will be the answer for this case? So you can see that what you have to do in this question is you have to find the maximum XOR value for a subset, right? For any subset, for a subset, right? You have to find a subset such that the XOR value is maximum. Okay, how do you do? How can we do this? So first of all, let me write it in terms of binary. So this is 101. What is 4? 4 is nothing but 100. What is 2? So 2 is 1 and 0, right? So let us first of all have a look at the case. In this case, you can easily observe that the thing is, which is the most set bit, which is the most set bit, most or let's say MSB. Which is the MSB? Most significant bit, right? Most significant bit, most set bit, anything you can say. So if you see, so since there are only three numbers, right? Only 3 positions are there. That is, these are the 3 positions, and if you will look at this position, so you can easily observe that this 5 and this 4, both of them are having this this at this position, both of them are having 1, and this 2 at this position is having a 0, right? So that is why you can see that if you do a 5 XOR 4, so since you know that by doing a XOR of the same values, this will be what? 5 XOR 4 gives me 1, right? So 5 XOR 4 gives me 1, which reduces my answer, right? This, its binary form is 001 because both the bits are set. So that is why I should not be doing this, right? So that is why alternatively what I should do is, in that position I should try to either have odd number of ones, or I should try to have only one, right? Only one possible set 1. That is why only one set bit. So that is why what I can do is I can select 5 again and I can XOR 5 with 2. If I do a 5 XOR 2, then in that case what will I get? Let us have a look. if I do a 5 XOR 4, let's say I do a 5 XOR 2, in this case what will we get? 5 looks like this, 2 looks like this. You can see that now this is actually suitable for us for doing a XOR operation, because one bit is set in a particular bit, ith bit is set in 5 and ith bit is not set in 2, or you can say the ith bit, like this bit is set in 2 but this bit is not set in 5, right? So that is why in this case what will happen, I can see a lot of people are watching, please like the video if you haven't already, right? So you can see that for this case it will look like this: 1 1 1 and 1. What do we get? Does that mean? So 1 1 1 and 1 means 1 2 and 4. This gives us 7, right? So you can see that we got the answer 7. Let us try and do much variations, another variation. So if we do a 4 or 2, so 4 is nothing but 1 0 0, and 2 is what? 2 is 1 0. So you get a 1 1 0. But when you get this number, that is 6, is it bigger? No, that is not bigger, because 7 is the bigger number, right? So that is why if you will try to make more subsets, so you will get the approach that you will get the answer that 7 is the maximum possible that we can get, and that is actually the case, because since there are only 3 digits, so at most maximum all 3 can be set, and otherwise there can be no possible, right? If this is set, you get, if all these 3 are set, so this is 1, this is 2 and this is 4, so the answer can be maximum 7, and it is actually coming out to be 7. Otherwise there can be not any other answer, because the answer cannot be maximum than the most set bit, right? Because otherwise all the other bits cannot be set, because all of them are 0, right? So now let me move to the next case, which is pretty important for all of us. Also, one more thing, like how do you find the subsets, right? Let's say you had you had 2 4 and 5. So what will the subsets look like? One subset can be 2 itself, one subset can be 4 itself, one subset can be 5, one subset can be 2 comma 4, one subset can be, let's say, 4 comma 5, one subset can be, let's say, 2 comma 5, and all these types of subset. One subset can be 2 4 and 5 itself. So the total number of subsets is what? Total number of subsets is nothing but 2 to the power n, right? So will you generate all the subsets? If you think that you will generate all the subsets in this case, so you can see that if the value of n is 3, then the number of subsets will be what? Number of subsets will be 2 to the power n, that is 2 to the power 3, which gives us 8. So if there are only 3 elements, that is 2 4 and 5, you are getting 8 subsets. So similarly, if n value will increase, then it will not be possible for you to do this, right? I can see a lot of people are watching, so please like the video if you haven't done that, okay? Right, so that is why you cannot do this, right? Because when n is very large, when n will be large, so it will not be possible to generate all the test cases, right? So that is why if you try to generate all the subsets, then the time complexity for that code will be order of 2 to the power n, that is, its time complexity will be exponential, and when the n value is large, so it will give you a time limit exceed, right? So how do you overcome this problem? That is what we'll be discussing in this problem, right? So there is a concept. First of all, before going to that part, let's take the next test case. So the next test case is what? The next test case, let me have a look. So the next test case is 1. So if that is 1, let me take one test case from my side. Let's say I take 9 8 and another number, let's say I take 5, right? If I take 9 8 and 5, I can see a lot of people are watching, please consider liking the video, okay? So if I have 9 8 and 5, so in this case what will I do, right? That is the concern. So let's first do the indexing part, the binary. Let's write them in binary form. So this will be what? One bit will be set here, this will be 8 to 9. Everyone agree on this part? Okay, it got stopped. What the hell, man?